Have you ever wondered how the sun, so far away, can bring modern life to a sudden halt? Just 3 hours ago, the most powerful solar flare in decades erupted, sending shockwaves across the globe, not just figuratively, but literally. This unprecedented solar event has already disrupted satellites, GPS systems, and communication networks, with warnings of more severe impacts on the way. Solar flares, bursts of intense radiation from the sun, are not uncommon, but what we're witnessing now is a game changer. Technology, infrastructure, and even daily life are at risk. Scientists are scrambling to predict the flare's full impact as it barrels toward Earth's magnetic field. This video explores everything you need to know about this historic solar flare, its causes, its immediate effects, and what this could mean for the future of technology. Stay tuned. This could change the way we view our relationship with the sun forever. Why this solar flare is historic. The solar flare that erupted 3 hours ago is already being described as one of the most powerful in recent memory. Categorized as an X-class flare, the highest intensity classification, it has surpassed predictions for solar activity during this cycle. What makes this event so historic isn't just its sheer magnitude, but also the timing and potential impact. This flare coincides with a peak in the sun's 11-year activity cycle, marking a period of heightened solar storms. Solar flares of this scale release massive amounts of energy equivalent to billions of nuclear bombs exploding simultaneously. While the sun experiences such eruptions regularly, an event of this magnitude is rare and holds the potential to disrupt Earth in unprecedented ways. Historically, similar flares, like the 1859 Carrington event, caused significant geomagnetic disturbances, including telegraph system failures and auroral displays visible near the equator. Now, with our dependency on technology, the stakes are even higher. This event is particularly notable because of its direct path toward Earth. When solar flares erupt, they often eject a coronal mass, a cloud of charged particles. If Earth is in the path of this ejection, the particles interact with our planet's magnetic field, causing disruptions. Scientists are already observing geomagnetic storms triggered by this latest flare, with auroras reported far beyond their usual latitudinal boundaries. What truly sets this event apart is the vulnerability of modern infrastructure. In 1859, there were no satellites or digital communication systems to be affected. Today, however, everything from power grids to GPS and internet cables faces potential disruption. Experts warn that this could be a wake-up call to the fragility of our tech-driven world. Governments and scientists are now rushing to assess the risks and implement protective measures to minimize the impact of this historic solar flare. What are solar flares? Solar flares are bursts of intense energy released from the sun's surface due to magnetic activity. Imagine the sun as a massive ball of plasma, with magnetic fields swirling and tangling due to its rotation. When these magnetic lines snap or reconnect, the energy stored in them is unleashed as a solar flare. This process creates an explosion of radiation across the electromagnetic spectrum, from X-rays to visible light. These flares are categorized into classes A, B, C, M, and X, with X-class being the most powerful. The flare that erupted today falls into the X-class category, making it among the strongest observed in recent decades. These flares are often accompanied by coronal mass ejections, CMAs, which release billions of tons of solar plasma into space, traveling at speeds of millions of miles per hour. Solar flares don't pose a direct threat to human health because Earth's atmosphere absorbs most of the radiation. However, they can wreak havoc on technology. The radiation from a solar flare can disrupt high-frequency radio communications, GPS signals, and even satellite operations. This is because the burst of energy ionizes the upper layers of Earth's atmosphere, interfering with radio waves. Flares also impact Earth's magnetic field, causing geomagnetic storms that can damage power grids and create dazzling auroras in the sky. The stronger the flare, the more significant its effects. Scientists use instruments like solar telescopes and satellites to monitor the sun's activity and predict these events. Despite their efforts, predicting the precise impact of a solar flare remains a challenge, as today's event has demonstrated. Understanding solar flares is crucial not only for scientific advancement, but also for protecting modern technology. As we become increasingly reliant on satellites, communication networks, and digital systems, studying solar flares can help us prepare for their inevitable impacts on our world. The science behind solar flares. At the core of every solar flare lies the fascinating science of magnetic energy and plasma physics. The sun, a gigantic ball of gas and plasma, generates energy through nuclear fusion in its core. This energy moves outward, creating convective motions in the sun's outer layers, which in turn generate powerful magnetic fields. These magnetic fields twist, tangle, and sometimes snap, releasing immense amounts of energy. This is what we observe as a solar flare. A solar flare begins in the sun's atmosphere, specifically in its active regions, where magnetic fields are most concentrated. These regions often coincide with sunspots, darker, cooler areas on the sun's surface. As magnetic fields become increasingly stressed, they eventually reconnect, creating a sudden burst of energy that is expelled into space. Solar flares are not standalone events. They are part of a larger phenomenon called solar storms, which include coronal mass ejections, CMAs. While flares release radiation, CMAs eject massive amounts of solar plasma. When these charged particles reach Earth, they interact with the planet's magnetic field, creating geomagnetic storms. The radiation from solar flares travels at the speed of light, meaning it reaches Earth within minutes. This radiation primarily affects the ionosphere, a layer of Earth's atmosphere critical for radio communication. High-energy particles from flares can also pose a risk to astronauts in space, damaging spacecraft and endangering missions. Today's flare, being an X-class event, exemplifies the immense power of the sun's magnetic dynamics. Scientists rely on tools like the Solar Dynamics Observatory, SDO, and space weather models to study these events and their potential impact. However, solar flares remain unpredictable, a reminder of the sun's untamed power and our planet's vulnerability to cosmic forces. How solar flares affect Earth. When a solar flare occurs, its effects on Earth depend on the intensity and direction of the burst. The immediate impact is felt in the ionosphere, where high-energy radiation ionizes atmospheric particles. This can lead to disruptions in radio signals, particularly those used for aviation and maritime navigation. GPS systems, which rely on precise timing signals, can experience errors or temporary blackouts. The charged particles from solar flares also interact with Earth's magnetic field, creating geomagnetic storms. These storms can induce electric currents in power lines, transformers, and other infrastructure, potentially causing large-scale power outages. In 1989, a geomagnetic storm triggered by a solar flare caused a blackout in Quebec, leaving millions without electricity for hours. Satellites are especially vulnerable during solar flares. Increased radiation can damage their electronics, reduce their operational lifespans, and degrade their solar panels. Communication satellites may experience signal loss, disrupting television broadcasts, internet services, and phone calls. In addition to technology, solar flares have a more visible effect: auroras. These colorful displays, commonly known as the northern and southern lights, occur when solar particles collide with Earth's atmospheric gases. Today's solar flare is expected to produce auroras visible much farther south than usual, offering a rare celestial spectacle. While solar flares are natural phenomena, their impacts remind us of our dependency on technology. Understanding these effects is critical for developing strategies to mitigate their risks, such as hardening power grids and creating better early warning systems. As today's event shows, the sun's activity can profoundly affect our interconnected world. Details of the latest solar flare. The solar flare that erupted 3 hours ago is an X-class event, one of the most powerful classifications of solar activity. Detected by NASA's Solar Dynamics Observatory, the flare originated from a particularly active sunspot region on the sun's surface. This sunspot had been monitored for days due to its high magnetic complexity, signaling the potential for a significant flare. Unlike smaller flares, X-class events release vast amounts of energy capable of disrupting technology on Earth and in space. This flare sent a burst of X-rays and ultraviolet radiation into space, which reached Earth's atmosphere within minutes. Reports from around the globe indicate widespread disruptions in high-frequency radio communications and navigational systems. In addition to radiation, this flare released a coronal mass ejection, CME, aimed directly at Earth. Scientists are now tracking the CME, which is expected to arrive within 24 to 48 hours. When it does, it could trigger geomagnetic storms strong enough to disrupt power grids, satellites, and even pipelines. Auroras are another anticipated effect of this flare. Skies across regions far south of the usual auroral zones, including parts of Europe and the United States, are expected to light up with dazzling displays. Social media is already buzzing with images and videos from amateur astronomers capturing the first signs of this phenomenon. The flare's magnitude has also raised concerns about long-term impacts on technology. Communication networks reliant on satellites, including internet services and financial systems, face potential outages. Airlines have rerouted some high-altitude flights to avoid increased radiation exposure. This event is a stark reminder of the sun's power and its ability to disrupt our modern way of life. While scientists work to predict and mitigate such impacts, today's flare is a wake-up call for global preparedness against space weather threats. Technology in danger. The solar flare that erupted 3 hours ago has placed modern technology in a precarious position. As the flare's radiation hits Earth's magnetic field, it creates a cascade of effects that threaten various forms of technology we rely on daily. One of the most immediate risks is to satellites. Satellites orbiting Earth are exposed to increased radiation levels, which can damage their electronics, disrupt communication signals, and even shorten their operational lifespan. GPS systems are another critical technology at risk. The ionization of the upper atmosphere caused by solar radiation can distort GPS signals, leading to errors in location tracking. This is particularly concerning for aviation, maritime navigation, and even everyday smartphone users. Pilots and sailors depend on accurate GPS data, and even slight disruptions can pose safety risks. Power grids on the ground are also vulnerable. Geomagnetic storms, which often accompany powerful solar flares, induce electrical currents in power lines and transformers. These currents can overload the systems, causing blackouts and damage to critical infrastructure. The 1989 Quebec blackout, which left millions without power, was triggered by a similar event. Communication networks face disruption as well. High-frequency radio waves, used by pilots, emergency services, and military operations, are especially susceptible to interference. This can lead to temporary communication blackouts, which are already being reported in some regions. Beyond direct technological impacts, the financial implications are staggering. A prolonged solar storm could lead to economic losses in the billions. From halted internet services to delays in financial transactions, the ripple effects would be felt across industries. The global community is increasingly aware of these risks, with experts calling for stronger mitigation measures, such as hardening power grids and shielding satellites. This flare serves as a stark reminder of our dependence on fragile technology and the importance of preparing for such cosmic events. Auroras across the globe. One of the most visually striking effects of a powerful solar flare is the appearance of auroras. These natural light shows occur when charged particles from the sun interact with Earth's magnetic field and atmosphere. Today's solar flare, being one of the strongest in decades, has sparked auroras that are expected to extend far beyond their usual polar regions. Auroras are typically confined to high latitudes near the Arctic and Antarctic circles. However, the intensity of this solar flare has caused a geomagnetic storm so powerful that auroras are being reported in areas much farther south. Regions in Europe, North America, and even parts of Asia are preparing for a rare glimpse of this celestial phenomenon. The science behind auroras is as fascinating as the display itself. When solar particles collide with atmospheric gases, they excite the gas molecules, causing them to emit light. The color of the aurora depends on the type of gas and altitude of the interaction. For instance, green auroras are caused by oxygen molecules, while nitrogen produces red and purple hues. Social media platforms are already buzzing with stunning images of auroras captured by sky watchers. From vivid green arcs lighting up Iceland's skies to pink and red streaks seen in parts of Canada, this solar flare is creating a visual feast for the planet. The phenomenon isn't just beautiful, it's also a reminder of the sun's power. Historically, auroras have been associated with major solar storms, such as the 1859 Carrington event. That storm produced auroras visible as far south as the Caribbean. Scientists believe that today's event could rival some of these historic occurrences. For those hoping to catch a glimpse, clear skies and minimal light pollution are key. As this rare opportunity unfolds, it serves as both a spectacle and a warning of the far-reaching impacts of solar activity. Impact on GPS and navigation systems. GPS and navigation systems are among the most critical technologies affected by solar flares, and today's event is no exception. The radiation emitted by this powerful flare has ionized the Earth's upper atmosphere, particularly the ionosphere, where GPS signals travel. This ionization disrupts the precise timing and location data that GPS systems rely on, leading to errors or even complete failures. The aviation industry is one of the hardest hit sectors during solar events like this. Pilots use GPS for accurate navigation, especially on long-haul flights over oceans and remote regions where ground-based navigation aids are unavailable. Airlines have already reported deviations in GPS accuracy, prompting rerouted flights to ensure passenger safety. Similarly, maritime navigation faces challenges, with ships relying on GPS for safe travel across international waters. Everyday users also experience disruptions, although they might not notice them immediately. Smartphone navigation apps, car GPS systems, and delivery services that depend on GPS data could face inaccuracies. Even minor timing errors in GPS can lead to cascading problems in other industries, such as telecommunications and financial services, which rely on GPS for precise time synchronization. Beyond GPS, other navigation systems like GLONASS, Galileo and Beidou are also affected by solar activity. The global reliance on satellite-based navigation makes solar flares a significant concern for multiple sectors. Engineers are now working to develop backup systems and error correction algorithms to mitigate these risks, but the current event underscores how vulnerable these technologies remain. This solar flare is a stark reminder of the interconnectedness of our technological systems and their susceptibility to cosmic events. As scientists continue to monitor the flare's effects, governments and industries must prioritize resilience in the face of such inevitable occurrences. Effects on aviation and space travel. Today's solar flare has sent shockwaves through the aviation and space industries. Solar radiation can be particularly dangerous for high-altitude operations, as the atmosphere provides less shielding from cosmic rays at such altitudes. Airlines are already taking precautions, rerouting flights that traverse polar regions, where radiation exposure is highest. The polar routes, commonly used for flights between North America and Asia, are particularly vulnerable during solar storms. Increased radiation can pose health risks to pilots and passengers, especially those on frequent flights. Airlines also face communication disruptions, as high-frequency radio signals used for communication in remote areas are severely impacted by the ionization caused by solar flares. Spacecraft and astronauts face even greater risks. Radiation from solar flares can damage spacecraft electronics, disrupt onboard systems, and pose health hazards to astronauts. The International Space Station, ISS, is currently monitoring radiation levels closely, with contingency plans in place to protect astronauts from prolonged exposure. Satellites, which are critical for communication, weather monitoring, and scientific research, are also at risk. Solar radiation can interfere with their operations, degrade their solar panels, and increase drag on satellites in low Earth orbit, shortening their lifespan. Some satellites have already reported minor disruptions, raising concerns about long-term effects if the storm persists. The aviation and space industries are constantly improving their readiness for solar events, but today's flare highlights the challenges they face. From ensuring passenger safety to safeguarding valuable equipment in orbit, the stakes are high. As this event unfolds, it serves as a reminder of the need for robust protective measures against the sun's unpredictable behavior. Potential blackouts and power disruptions. One of the most alarming risks posed by solar flares is the potential for widespread blackouts and power disruptions. The massive amounts of charged particles released during a flare interact with Earth's magnetic field, creating geomagnetic storms that induce electric currents in power lines and transformers. These geomagnetically induced currents, GICs, can overload and damage electrical infrastructure. Power grids in high-latitude regions, such as Canada and Scandinavia, are particularly vulnerable to geomagnetic storms. During the 1989 Quebec blackout, a geomagnetic storm caused transformers to fail, plunging millions into darkness for hours. Today's solar flare has raised similar concerns, with energy companies on high alert for signs of grid instability. Transformers, a critical component of power distribution, are especially at risk. Overloaded transformers can overheat and fail, leading to cascading outages across interconnected grids. Repairing or replacing these components is time-consuming and costly, making prevention a top priority for utility providers. Beyond power grids, pipelines are also affected by geomagnetic storms. The induced currents can accelerate pipeline corrosion, increasing maintenance costs and safety risks. Communication networks that rely on power infrastructure, such as mobile and internet services, also face disruptions. Governments and energy providers are now focusing on mitigation strategies, such as installing monitoring systems to detect geomagnetic disturbances in real time. Some grids have implemented automatic shutdown systems to prevent widespread damage, but these measures can only do so much. As today's solar flare continues to unfold, the potential for power disruptions looms large. This event underscores the need for greater investment in resilient energy systems and underscores the delicate balance between human technology and cosmic forces. Threats to internet and communication. The solar flare's potential impact on global internet and communication systems is a growing concern. Solar radiation disrupts the ionosphere, the layer of Earth's atmosphere responsible for reflecting and transmitting radio signals. This interference can interrupt long-distance communication networks, especially those reliant on satellite links. Undersea internet cables, critical for global connectivity, are indirectly vulnerable. While the cables themselves are shielded, their reliance on ground-based power stations makes them susceptible to geomagnetic storms caused by the flare. A geomagnetic surge could fry transformers and power units, cutting off internet access in affected regions. The ripple effect would hinder international financial transactions, cloud computing services, and global business operations. Satellites used for broadcasting and internet services are also at risk. Increased radiation can damage sensitive onboard electronics, cause data corruption, and reduce the lifespan of satellites. Some satellite operators have already reported signal disruptions and errors in positioning data. In remote areas where high-frequency radio is a primary means of communication, disruptions could be life-threatening. Emergency services, aviation, and maritime operators rely on stable communication networks, and interruptions could delay critical responses. The broader implications extend to industries like e-commerce, streaming platforms, and social media, all of which depend on uninterrupted connectivity. Even a brief outage in major hubs could lead to billions in economic losses. Governments and tech companies are collaborating to improve infrastructure resilience, including hardening systems against solar radiation and ensuring backup power sources for key nodes. Today's solar flare serves as a reminder of how interconnected our world has become and the vulnerabilities inherent in a tech-driven society. As communication systems brace for potential outages, this event highlights the urgent need for more robust solutions to protect against solar activity. A reminder of our cosmic fragility. Today's solar flare is a humbling reminder of humanity's vulnerability to cosmic events. Despite our technological advancements, our world remains deeply connected to and dependent on the forces of nature. Solar flares, while awe-inspiring, reveal how fragile our modern systems are in the face of such overwhelming power. The sun, which sustains life on Earth, also has the potential to disrupt it. This duality underscores the delicate balance that allows humanity to thrive. Events like today's flare highlight the unpredictable nature of solar activity and its cascading impacts on Earth's technology, economy, and even daily life. While we often view technology as a shield against nature, solar flares expose its limitations. Our reliance on satellites, power grids, and communication networks makes us more susceptible to disruptions than ever before. What was once a minor inconvenience for telegraph operators in the 19th century now has the potential to cause global outages. This flare also challenges humanity's perception of control. It serves as a cosmic reminder that we are part of a much larger system, one that operates independently of human will or technology. Our preparedness for such events is a testament to human ingenuity, but it also highlights areas where we must improve. Governments and organizations are now investing in solar weather forecasting and mitigation strategies. However, these efforts are still in their infancy. The need for international cooperation to address solar threats is becoming increasingly urgent as the impacts of solar flares don't respect national borders. As we watch the effects of this flare unfold, it reminds us of our place in the universe. It's a call to appreciate the delicate equilibrium that sustains our existence and to work collectively toward protecting our future against such cosmic phenomena. Could this lead to a Carrington event? The solar flare that erupted today is already drawing comparisons to the infamous Carrington event of 1859, one of the most powerful geomagnetic storms ever recorded. That historic event disrupted telegraph systems worldwide, caused electrical fires, and produced auroras visible as far south as the Caribbean. The question now is whether today's flare could lead to a similar event. Solar flares of this magnitude have the potential to create geomagnetic storms capable of rivaling the Carrington event. The coronal mass ejection, CME, associated with today's flare is traveling toward Earth, and its impact will be determined by the strength and alignment of its magnetic field. If the CME's magnetic field is southward, it could interact more intensely with Earth's magnetic field, increasing the likelihood of severe disruptions. The Carrington event occurred at a time when technology was far less advanced. Telegraph systems were the height of communication, and their failure, while significant, didn't have the same global repercussions that a similar event would today. Modern society's dependence on electricity, satellites, and the internet makes a repeat of the Carrington event far more catastrophic.